Alright, you guys want details? We'll go for details here. Antonio and Hillbilly still refuse to produce a scale model of the Earth and the Moon according to heliocentric reality, which include the scale distance between the two, so they can finally prove or disprove their east to west shadow 2017 eclipse claim. But since Antonio can't think and Hillbilly can't read, I guess I got to go into a little bit more detail, so go get yourself some coffee. This is their claim. These aren't my words, these are their words. This is their claim. And they didn't just say it once off the cuff, this is their claim.
If you start to spin the globe, and the globe move faster than this, because this takes 28 days to spin around the Earth axis. This takes 24 hours. That's 1 day. 1 day, 28 days. 1 day, 28 days.
This is going to carry on spinning faster than this is orbiting. And the shadow, relative to the surface of the Earth, is going to go east to west, not west to east.
This is going to be like the same as the other video. It goes around the Earth 1 time every 28 days, and respect to the Earth's surface, the shadow is going east to west.
You can't argue with that. There's no arguing with it. No matter how distant you move the moon in a model, no matter what you do, what I say stands. The model, the heliocentric model that would describe what the eclipse is going to do is not what their heliocentric model says is happening. There's no way of arguing out of that. So the distance argument is nonsense. It doesn't work. The model is broken. Their model is broken. You've broken the model, mate.
The umbrum's got to go from east to west if we're spinning into it.
Yep.
Spinning into it. The Earth is spinning in the right direction. The moon is orbiting in the right direction, but we're not getting the heliocentric results using heliocentric math.
Figuring they were just confused, I built a scale model to show how it works. But then they came back with a video model and a wildly out of scale Earth-Moon model. The point of their complaining was to discredit my model because it showed how it works just fine. And in that discrediting, they wanted to say that because I trimmed off 8 hours out of 655.7 hours on the 27.322 day cycle, apparently I created a west to east shadow transit with that 8-hour difference. And yet they still haven't produced a scale model which shows the scale moon's shadow moving east to west across the globe, nor have they displayed how the eclipse works on a flat Earth either. So again, I decided to do it for them. But this time I wanted to seek what the ratio of Earth rotations to one moon orbit would be required for the shadow to actually go east to west to scale. Because one part of their claim is sound, and that is the Earth is rotating faster than the orbit of the moon, so at some point it has to actually happen. Now I kind of said in jest in my last video that it would be above 54 Earth rotations to one moon orbit. But after doing this research, 54 wasn't even close. So here's my ratio model. Please pay attention to it this time. Pay attention to the scale of the model before you mess it up again in your rebuttal. Because honestly, Hillbilly, had you read this slide that you put up there, calling it fancy, you would have read the words 360-degree protractor and would have known that the protractor was not the Earth. So let's do the math. Broken up into 3 parts. First part is the cycle. This is pretty basic stuff. This is working out the ratios and the amount of degrees of rotation of the Earth per those ratios. Pretty simple. Every rotation 360 degrees times how many rotations. Pretty easy. Second part is the measured period. Now in this model I'm about to show you, I have 4 moon-sized objects, just for comparison. The closest to the Earth is of course Hillbonio. And since the closer an object is, the longer the shadow transit time is, we'll use Hillbonio's angle as the base. I have placed Hillbonio's axis at 30,000 kilometers from the Earth's axis. This makes Hillbonio's transit across 2 parallel lines representing the diameter of the Earth 30 degrees. So for the remainder of the testing, we'll be using this 30-degree period of the Moon's orbit. Then I use simple multiplication to determine the Earth's degrees of rotation during Hillbonio's 30-degree transit. And that was pretty simple. 1-to-1 scale is 1 times 30. That means the Earth rotated 30 degrees. 5-to-1 is 5 times 30. 10-to-1, 10 times 30, and so on. Pretty easy stuff. Now in the model, the Earth doesn't really look like the Earth. I have it marked up with longitude lines. And I synchronize the middle of the test with a specific marking that's on the sphere. The value in this column it was more for my use when I was keyframing the animation. But you can use it to observe the amount of degrees that the Earth rotated before and after the mark. So the last part is the blue line. The blue line in the model is static to the Earth's rotation. The start and stop locations are the protractor angles, where the Earth will start and stop rotation for the measured period. Okay? And the last column is how many complete rotations the Earth will make at each ratio for the measured 30-degree transit. And those numbers, they're not in degrees, those are in whole numbers, how many rotations the Earth is going to make. If you look down there, for example, at 27, the Earth is going to rotate 2¼ times in this 30-degree period. I'll be plugging those numbers into the model's motion, and you'll see that in the end animation. The model I'm using is actually the same one that I used before. I changed a little bit of the colors, and I added 2 moons, just so you could do some comparisons. Still with me, right? First of all the distances and sizes, the units are kilometers. The scale is 1 to 100, which means when you see numbers in my 3D program, 1,000 kilometers is actually 10 units. Okay, it's just moving the decimal point 2 points to the left. All the numbers are the same, just moving the decimal point 2 points to the left. Okay, so first I have the Earth, and you can see here, I'm going to say these measurements without the decimal point. The radius of the Earth is 6,371 kilometers. Then we have the moons. All 4 moons that I'm going to have on here are all the exact same size. The moon's radius is 1,737 kilometers. And then I put in a distance ladder, because there's no grid involved in the end animation. So I built a ruler, and that ruler is the diameter of the Earth, which is 12,742 kilometers, and the width that is listed here is actually the full distance that I am using, which in this case is 400,000 kilometers. We good so far? All right, and here's the raw appearance before the actual rendering. Here's the Earth, not the big circle, the ball in the middle. There's the Earth, and here's Hillbilly at 30,000 kilometers. Here's what I'm calling orange moon, just because of the color, at 120,000 kilometers. Here's yellow moon, also because of the color, you'll see that in a minute, at 250,000 kilometers. And then there is the moon, which is the green one. And the moon, you can look it up, is 385,000 kilometers. That is the average distance of the moon. Here's the ruler. It's 400,000 kilometers long, with a line at every 10,000 kilometers. And these are protractors, okay? They are protractors. They are only used for visualizing the measurements and also to show that no lines are bending or anything like that. They are showing all degrees associated with this model. The one around the Earth goes a whole 360 degrees. The other ones, they only go as far as you can see them there. They're protractors. So, and then this is what the render looks like. These are protractors. And on each one of the renders you are going to see, along with the math, which I'm going to blend in for each particular ratio that I'm showing. This is the Earth. These are the rotations of the Earth. Here's the moon, how many orbits it makes. Protractors, not physical items. So, and throughout the animation, you're going to also see a couple other lines. 2 primary lines, which is the purple one. That is the angle from the center of the Earth to the center of the moon, with the other 2 moons along the same line. Then the blue line is the Earth's angle, which you can count and watch go around as much as you want to. The additional lines here, there is a red, an orange, a yellow, and a green line, and they are the moon's umbra line, yellow moon's umbra line, orange moon's umbra line, and Hillbilly's umbra line. They will all remain going perfectly from right to left throughout their transit. Now their transits are always going to be 30 degrees. That is 15 degrees below the middle there and 15 degrees above the ruler there. The transit on every one of the runs of this model, they are all going to look identical. The comparison here is that information versus the rotation of the Earth. Now, like I said, on the Earth, I didn't put any landscape on it. Instead, I just drew out longitude lines, 1 line for every 10 degrees longitude. I cut it in half so it was easier to notice when the Earth had turned to the backside. And then I put these 2 big black marks on there just to cut it further in half. Now the black mark on the left there is actually going to be the center point on every run. You'll see that in a minute. This is the view from right in front of Hillbilly looking at the Earth. You'll see a green line, a yellow line, an orange line, and a red line, all from their respective moons. And you will also notice that they move different speeds because of the fact of their different distances from the center of the orbit. These lines will also look identical every single time you see this view on all 11 runs that I'm about to show you. Nothing's going to change there. All that is going to change is the speed of the rotation of the Earth. All of the demonstrations, all the runs of the cycle are going to center right here. I set it up that way so you can measure it every time the exact same way. Now, one little point I want to say here before somebody gives me snot about this. This cycle and this demonstration do not have anything to do with north and south, because we all know how good Antonio is with north and south anyway. The north-south offset of the umbra lines are not due to their distance. I have only separated them so that you can see them as well as possible, and that's it. Nothing else special about that. So now that I got all that information, let's find out exactly how fast does the Earth need to spin for the umbra of the moon to go east to west, as Antonio and Hillbilly claim. Pay attention to the numbers. I've even stopped it and started it, okay? Didn't worry about the aesthetics this time because I wasn't looping anything. You can play them back to your heart's content. There's one at the very end. I actually had to slow down because it was very difficult to tell how fast the Earth was spinning throughout the 30-degree transit. So I only slowed it down by half. All the other numbers about it are fine. You can check them over. I had to show it at a slower speed. That's all.
One day, 28 days. 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 One day, 28 days.
And the shadow, relative to the surface of the Earth, is going to go east to west, not west to east.
So, one day, 28 days. One day, 28 days. One day, 28 days.
East to west,
One day, 28 days. One day, 28 days. One day, 28 days.
east to west,
One day, 28 days. One day, 28 days. One day, 28 days.
east to west,
One day, 28 days. One day, 28 days.
not west to east. East to west, east to west, east to west, not west to east.
Hillbilly, over to you.
27.322.
28 days. 28 days.
27.322.
28 days. 28 days.
Shame on you.
One day, 28 days. One day, 28 days. 28 days.
27.322. You need to go back to elementary. 27.322.
28 days. 28 days.
Don't fuck with Hillbilly.
One day, 28 days. One day, 28 days. 28 days.
Don't make me go full blown Hillbilly on your ass.
28 days. 28 days.
You know I do it, goddammit.
One day, 28 days.
East to west,
One day, 28 days. One day, 28 days. One day, 28 days.
east to west,
One day, 28 days. One day, 28 days. One day, 28 days.
east to west,
One day, 28 days. One day, 28 days. One day, 28 days.
east to west,
One day, 28 days. One day, 28 days.
not west to east. East to west, east to west, east to west, not west to east.
So, one day, 28 days. One day, 28 days. One day, 28 days. One day, 28 28 days. 1 day, 28 days. 1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
And the shadow, relative to the surface of the Earth, is going to go east to west, not west to east.
So, 1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
East to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days.
not west to east. East to west, east to west, east to west, not west to east.
Hillbilly, over to you.
27.322.
28 days. 28 days.
27.322.
28 days. 28 days.
Shame on you.
1 day, 28 days. 1 day, 28 days. 28 days.
27.322. You need to go back to elementary. 27.322.
28 days. 28 days.
Don't fuck with Hillbilly.
1 day, 28 days. 1 day, 28 days. 28 days.
Don't make me go full blown Hillbilly on your ass.
28 days. 28 days.
You know I do it, goddammit.
1 day, 28 days.
East to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days.
not west to east. East to west, east to west, east to west, not west to east.
So, 1 day, 28 days. 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 1 day, 28 days.
And the shadow, relative to the surface of the Earth, is going to go east to west, not west to east.
So, 1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
East to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days.
not west to east. East to west, east to west, east to west, not west to east.
Hillbilly, over to you.
27.322.
28 days. 28 days.
27.322.
28 days. 28 days.
Shame on you.
1 day, 28 days. 1 day, 28 days. 28 days.
27.322. You need to go back to elementary. 27.322.
28 days. 28 days.
Don't fuck with Hillbilly.
1 day, 28 days. 1 day, 28 days. 28 days.
Don't make me go full blown Hillbilly on your ass.
28 days. 28 days.
You know I do it, goddammit.
1 day, 28 days.
East to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days. 1 day, 28 days.
east to west,
1 day, 28 days. 1 day, 28 days.
not west to east. East to west. East to west. East to west. Not west.
You can't argue with that. There's no arguing with it. No matter how distant you move the moon in a model, no matter what you do, what I say stands. So the distance argument is nonsense. It doesn't work.
The Umbram's got to go from east to west if we're spinning into it.
So, now that you've watched all that, hope you like the music. This means that anywhere between 0 rotations and 79 Earth rotations per one moon orbit, the umbra of the moon, to scale, will move from west to east. So me trimming my demonstration by the sum of your combined IQs, yes, that's 0.322, was about as significant as your claim. Got any questions? Oh, and by the way, once you decide that you've found a way to make this somehow work on the flat Earth because it happens to be in the northern hemisphere this time, now do it with these. Y'all have a nice day.
Oh my god.
One day, 28 days. One day, 28 days.
East to west.
One day, 28 days. One day, 28 days. One day, 28 days.
East to west.
One day,